Hi guys, I know there's a lot of you guys out and I've had a lot of questions today about how to finish the lab at home, so I'm going to really quickly walk through it. Hopefully a video explains it better than just typing it out, and hopefully it takes less time for both of us. So if you can see back behind me, I don't know if it'll be flipped when I send it to you right now, it's mirrored, but you guys can see what they're doing today. So this is what your graph is going to somewhat look like. I'm going to write it out on paper as well for you guys. So if you have data on this paper already, by all means, please use that data. If not, I will be sending you data shortly. At the bottom of this, it tells you, how to graph, what to graph, all of that, but I'm going to walk through it with you quickly so that you guys know what's going on as well. So I have a fake graph here that I am using to show you guys what's going on. You will need generations on your x-axis, just like it is in the background. We're going to have generations. You should have 20 if you got done, but if you did not get done, I don't want you to freak out. If you only have 10 or 15, that is totally fine. We'll just graph with those. If you did 10 or 15, you can go every other. I'll pause and show you what I mean by that in just a second. This is what I mean by every other, is how when I wrote those down, I skipped 2, wrote my first number, skipped 2, wrote my next number. But notice it only goes to 18. So if you had all 20, you will have to scrunch them in. Okay, so that's my x-axis. My y-axis, just as it's labeled over here, should be population. Okay, so population. And this is going to vary depending on your group's data. Your highest number can go up towards the top, preferably. We don't just want to keep it down here. We want to try to use as much of the graph as we can. But if you had, like if you were in the group that had 180 rabbits, you got to have 180 up there. If you were the group that only had 13 rabbits max, then you need to figure out a way to try to space your 13 up here so it's not halfway down your page, okay? So that will vary. I'm going to go ahead and number this in the data that I'm going to use to send to you guys in case you don't have data. That way you guys can kind of copy me if you use that data. So just one second. Okay, so the data I have has a max population of 16, it looks like, so I will be sending this out in an email for you guys who need it, or I might post it on class pages because we just lost a lot more people the last half of the day. So we are skipping every other on my y-axis because I'm only going up to 16 as my max number, so I don't have to worry about going that far up. But this way my 16 is not down here. It's at least spreading it out some for me. So that's what I am doing with this. The other thing for this, so if you read at the bottom of this where it says graph, okay, on the next page, make a line graph on the graph paper provided, show the changes in the lynx and rabbit population over time. You will need to make sure to indicate or to include a title, label your X and Y axis with units, and a color-coded key. Choose between graphing the starting populations of each generation or the ending population. So you get to choose which one you want to do. My suggestion, if you were the group who had 180 in your starting generations, you might want to record your ending populations just so it's easier and you don't have to go up to 180. If you had really low numbers, I would use your starting population because it gives you the bigger numbers. So for mine, I'm using one from a group who emailed it to me. So I am actually going to use their starting data because it's a little bit more exciting than their ending data. Okay, so because I'm using the starting data, I need to be sure that my title reflects that. So my title is going to be about the starting population. Okay, so my graph is labeled. I am ready to go. Now I just need to look at my data table. I transferred it over to paper to make this a little bit easier. And I need to remember that I am doing my starting population. So here's my suggestion. If I were you, which I am pretending I am, so I'm going to do this. If I were you, I would take sticky notes or some other piece of paper and cover up whichever one you are not using. So I am going to cover up my ending population so I do not get confused. And now I only need to focus on my starting data. With that being said, the first thing I am going to do is only worry about one set of data at a time. So the first thing I'm going to do is only look at my links numbers. Okay, so I'm going to go through. I'm going to go to generation 1, and I am going to go up 1 because my data table says I have 1. I only have 1 links clear through until generation 6. Okay, so I'm going to go through and pencil this in. So for generation 1, I have 1, generation 2, 1, generation 3, 4, clear to 5. At 6, I go to 2. So you guys can see that I stay at 1 for generation 1, 2, 3, 4, 5, and then at 6 you see I go up to 2. My data then goes back to 1, and then I go up to 2, back to 1. So I'm going to fill that out, and I'll come back. I am just graphing, just putting down these dots, just the one circled. Okay, so I'll be right back after I get those down. Okay, so again, sorry, I keep situating myself. Again, just graph your links numbers. So all I have on this graph right now are my links numbers. Now, while I only have those numbers on my graph, I'm going to connect my dots. Okay, so I will be back to show you guys what that looks like here in just a second. Okay, so now that we have those graphed, I can connect them and only worry about them. I did my dots in pencil and then went over them with whatever color I wanted. Be sure you're not using Sharpie because there is a back that you're going to have to fill out, and notice with a Sharpie it does bleed through. So connect your dots with whatever color or pattern you want to do. Notice I did not connect my 0. Okay, so it just starts at 1 and 1. I'm going to do the same thing using the same data, but this time only looking at my rabbit numbers. And I'm going to go through each generation and fill that out. Don't forget to use your first number as this top 3 that's filled in for you. Don't skip that. So I'm going to have generation 1 has 3, generation 2 has 3, generation 3 has 4, 4 has 4, and so on. Okay? This is where things get a little weird because the numbers are jumping everywhere, right? I go from high to low to high to low over here, so you have to be careful when you go to connect those. If you want to connect them in pencil first and then connect them if you're using marker or something that's not going to erase. So I would go through and connect them with pencil first to make sure you're actually going in the right order. A lot of people had to ask for whiteout today, so just be careful with that. I'll show you guys what it looks like when I have that all connected. Okay, so here is what I look like now that I have went over it with pencil first to make sure I connected the right dots, and then I did my dashed line with, I'm using Sharpie, you shouldn't because the back, it bleeds, okay? So that is all connected, and so there is my graph. So again, I have a title, my y-axis, my y-axis is labeled, my x-axis is labeled, and I have a nice little key of what's what. So if you do use colors, be sure you give me a key. Notice my title does tell me that it's the starting population, so be sure you have that there as well. That is it for the graphing part. For the sake of the potential of having questions, I do want to quickly run over the analysis and your conclusion. Okay, so quickly I will run through that. Your analysis has 3 separate parts. It should be, you can number it if you want, like of what's going on, just for simplicity's sake, but you do not need to. It should be in paragraph form. You guys know how I am, especially on this first one. Please list them instead of doing full sentences. So the first one says, experimental setup, do not rewrite the procedures, but do explain the independent variable and the dependent variable. I am fine with you guys giving me an IV and a DV for that. Okay? Remember, your dependent variable is what we are measuring, and that is typically on your y-axis. Okay? Your x-axis is usually our independent variable, which is what we have control of as the experimenter. So I am in control of my independent variable. And I know it seems weird, but for this one, we're going to call the generations our independent variable because we are changing how many we do. The dependent variable is what we are measuring. I will let you guys decide what that is. It's your y-axis on your graph. The second part to this says, refer to your graph and explain what it shows. Look at patterns as well. How did one population change in response to the other? Some of these graphs might not be perfect. That's okay. Do your best to give me what you see. If one population goes up, do you see a noticeable increase in the other? If one goes up, do you see a noticeable decrease in another? So talk about that. The third part to your analysis is error analysis. So this one a lot of people lose points on because it says to write out at least 3 ways. 3 ways your data may not be completely accurate, and include a specific solution to prevent this problem in the future for each error. Do not tell me that you did bad math. Okay, we've talked about this on the last few. If something went wrong, go fix it. But like if you dropped from too high and they kept partially landing on the meadow, that might be an error you want to talk about next time. I would hold the links down closer to the paper and let it go, because one error we saw repeatedly happen is that our links was barely on the meadow for repeated rounds. Okay, some other ones might be something about you didn't properly calculate between your doubling of rabbits, or you didn't properly count how many rabbits your links caught so that you could tell how much your links repopulated, those sort of things. So that is part 3 to your analysis. You should have 3 errors and a solution for each, okay? For your conclusion, does the data support your hypothesis or not? I don't know. You have to go back and look at your hypothesis that you made on your first page that we wrote right here at the top. So you will go back, look at what you write, or look at what you wrote and see if your personal data, so unless you're using the one I'm going to send, look at your graph and see if your personal data supported your hypothesis or not. And remember, it's okay to be wrong, okay? So you can be like, nah, did not match my hypothesis. The second part to this is real world application. Connect what you learned in this lab simulation about predation to how this relates to predation in a real community. So now we're stepping out of squares of paper, dropping them on another piece of paper, and thinking about this as an actual predation, like predator-prey relationship. Also include how competition may be related to predation based on what you observed during your lab. That might be a part where you refer back to how if 2 links landed on 1 rabbit, we had to decide who got it, right? And a lot of times that did kill off one for a lot of groups. So that might be something to discuss there as well. If at all you ever have a question, please email me, get a hold of me somehow. I will do my best to respond to you guys quickly. I know this is probably stressful for a lot of you. It's looking crazy on this end as well. So please reach out. I'm going to do my best to help you guys in any way, shape, and form that I possibly can. But yeah, in the meantime, stay healthy if you are healthy, and if you're not healthy, I hope you get better very soon. I look forward to seeing you guys back in the next few weeks. Have a great weekend. See ya.